Welcome to Precalculus Concept 25C underneath right triangle trig. We're going to use equal co-functions of complements to take a look at angles in triangles. There are three boxes. You need to get your graphing calculator out and make sure it is set to degree mode. So if you need to do that, go ahead and do that right now. Let's take a look at box 1 together, okay? So I want us to take a look at what the sine of 25 degrees is in the calculator really quickly. So just take your calculator out and plug along with me and figure out what is the sine of 25 degrees and then push enter. And you're going to see that we get, let's go to 4 decimal places, so 0.4226, 0.4226. So this is 0.4226. Okay, now I want to take our calculator and I want to do the cosine of 65 degrees. Cosine of 65 degrees and push enter. And you should notice that you get the exact, and I mean exact, decimal for decimal answer, 0.4226. So 0.422 and 6. Well, why is this the case? These are called co-functions, okay? Sine and cosine are a pair of co-functions. The co in front of sine for cosine stands for the complement to sine. Now you remember that back in geometry, complement meant two angles that added to 90 degrees. So take a look at this. 25 degrees and 65 degrees add to 90, and sine and cosine are co-functions, so therefore they are equal, okay? So why is this the case? So let's just say I have this labeled as A, this B, and this is C. So let's say I have a right triangle. If I'm interested in the sine of 25 degrees, okay, the sine would be the opposite side, which would be B over C. So if I just take a look and didn't actually know the lengths of the sides, I would say that the sine of 25 degrees is equal to a value of B over C. Now, if I take a look at the cosine of 65 degrees, the cosine is the adjacent to the hypotenuse, so the cosine of 65 degrees is equal to, oh, look at that, B over C. So you'll notice that they are exactly the same, regardless of, as long as you have a right triangle. There are two other pairs of co-functions in the trig family that exist. Tangent and cotangent are co-functions. So if I have 17 and 73, you'll notice that 17 and 73 add to 90. So if I take my calculator and I did the tangent of 17 degrees, you'd see that I would get this decimal. And remember, to plug in a cotangent, you have to go 1 divided by the tangent of 73 degrees because it's a reciprocal identity. And you'll notice you get the exact same thing, decimal for decimal. So if I wrote that out to 4 decimal places, it'd be 0.3057. So this is 0.3057 and 0.3057. So we have now learned that tangent and cotangent are co-functions, sine and cosine are co-functions, and secant and cosecant are also co-functions. So remember, to do secant, you would do 1 divided by the cosine of 44 degrees, push enter. And then to do cosecant, you would do 1 divided by the sine of 46 degrees, and push enter. And notice you get exactly the same decimal. As long as the two angles add to 90, and you have co-functions, you're going to get the same value. So we know that secant and cosecant are co-functions as well, and that value was 1.390. So 1.390, 1.390. So this is the idea and the reason behind co-functions. Okay, here are the co-function identities. I wrote them all down for you. I wouldn't necessarily say that you have to have these written down in your notes because they're all the same. All that you really need to know is that sine and cosine are co-functions, tangent and cotangent are co-functions, and secant and cosecant are co-functions. And the angle of one is going to be 90 minus that same angle in the other. One thing to note that is if your theta is in radians, then you would use a pi over 2 versus a 90 degrees. So again, I don't think you have to necessarily write these down, but just know that which ones are co-functions and then how to find them. Okay, box 3, let's do 2 examples together. It says find a co-function with the same value as the given expression. Okay, So the sine of 72 degrees. So the first thing you have to realize is that the sine's cofunction, trig function, is going to be the cosine. So the sine of 72 is going to be the same thing as the cosine of what? So you got to ask yourself, 72 plus what gets me 90? So 72 and 18. So this should be 18 degrees, right? So we can check and see in the calculator if I plug in the sine of 72 and push enter, and then punch in the cosine of 18 and push enter, we should get the exact same decimal for decimal. So the correct answer for that first one, part A, would be cosine of 18 degrees. Okay, what about the cosecant of pi over 3? Notice this is in radians, so we can still work with this. But you first have to identify, okay, cosecant and secant are cofunctions. And then I have to come up with pi over 2 minus pi over 3, because pi over 2 is the equivalent measure of 90 degrees. Notice over here we did, if I did 90 minus 72, that would give me the 18. So I'm doing the same thing over here. So get a common denominator of multiply this side by 2 over 2, multiply that side by 3 over 3. And now we get 3 pi minus 2 pi over 6. So we get pi over 6. So therefore the answer that I'm looking for is the secant of pi over 6 is the same value as the cosecant of pi over 3, because cosecant and secant are cofunctions, and pi over 3 and pi over 6 add up to pi over 2. Okay, box 4, here's a you try. Find a cofunction with the same value as the given expression, the sine of 48 degrees. Hopefully you got the right answer of cosine of 42 degrees. The reason this is true is because sine and cosine are cofunctions, and 48 and 42 are complementary angles.